और सब चलने दो।
People who interviewed for the position. I hope the department will be further strengthened by them. Today in the QS ranking, recently announced, the department ranked 7th among the Indian physics departments. Okay, behind IISc number 1, 5 old IITs from 2 to 6, and on the 7th position we are tied with IIT Guwahati, followed by TIFR. By saying this, in no way I imply that suddenly we are better than TIFR or many other institutions in India. But what I want to tell, that even when the IITs and IISERs have mushroomed all over the country, this department is holding its place under the sun, and we should be pleased with that. I must also emphasize that it would be foolish to pretend that we can't do better, and we must strive towards doing better for this department. The 4 parameters which are important, such as bringing large grants, publishing in good journals, getting invited to prestigious conferences in India and abroad, and guiding the students who do well in future must be our aim as a researcher, beyond teaching our students to the best of our ability. So without much pontificating, I would like to introduce our speaker, whom most of us know, but definitely our students and postdocs, new faculty member need his introduction. Professor Natarajan Panchpakeshan was a professor in the Department of Physics and Astrophysics, this department. He must have taught so many lectures in this room. Till his retirement in 1998, 25 years ago, he did his PhD from the University of Delhi, was a postdoctoral fellow at the University of Chicago, and worked as an assistant professor at the University of Wisconsin-Milwaukee in mid-60s before returning to University of Delhi as a faculty member. Besides being an outstanding teacher, he has major contribution in research in areas of general relativity, cosmology, and astroparticle physics. Some of his well-known works include particle motion in pulsar magnetic field, Hawking radiation, gravitational lensing, and the baryon asymmetry in the early universe. He is a fellow of the Indian Academy of Sciences, Bangalore. He also participated in science teaching programs at middle school in Hosangabad and Bhopal, Madhya Pradesh. It was one of the landmarks in India in teaching of school kids, Hosangabad school, and you should go and look at it. This was the introduction he sent us. Now I will add few stories. Recently, Professor Panchpakeshan celebrated his 90th birthday, and we were fortunate enough to be invited. First, he is the second oldest speaker that I am going to hear today. I have heard him earlier too. The oldest being Hans Bethe, whom I heard at the age of 92 in Caltech, where he talked about his latest work. I went to see him. I didn't go to listen to what Hans Bethe was talking. I literally went there to see him, that how Hans Bethe looks and how he gave a talk for 50 minutes, standing on the podium and giving the talk. Okay, it was an experience. Second, Professor Panchpakeshan, which he doesn't like to tell, but I'm taking the liberty, sir. He served as an IS officer in Tamil Nadu in his younger days, before I believe he came to research. So at that time, if you became an IS officer and you got your home state, you have to be in the very top rank. Okay, I will not go beyond that. The third experience I have, I'm going to quote, when I was a postdoc at Fermilab, rather University of California, Riverside, but stationed at Fermilab. He came to visit Fermilab via Waxahachie SSC, if I remember correctly. Since Professor S. Chandrasekhar was known to him, I know he was related to him, he needed to give Professor S. Chandrasekhar a contact number for him, and he gave Professor S. Chandrasekhar my office phone number. So one day, Professor S. Chandrasekhar called me. When I picked the phone around 11 a.m., he said, I am Chandrasekhar. It takes you a while to get to your senses that you are hearing Professor S. Chandrasekhar, Nobel laureate, an ideal for any Indian. So, that was my 30-second or 1-minute introduction to him. I had a message for Professor Panchpakeshan, which I gave him. That was my first and last interaction of him with Professor Chandrasekhar for a minute. Was never fortunate enough to meet him or listen to his talk. He passed away a few years later after that. So much ado, I invite Professor N. Panchpakeshan for his talk on life and work of Professor A.N.Mitra. Thank you. Professor Panchpakeshan. Kirti, now you can bring the talk. Yes, sir. Oh, God, yeah. Yes, yeah. Just check it once. No, not this. Right. Yeah. Or how? No. Right now it's not visible, but if you come close to the mic, then I would just like to. No, column mic is not given for that. Okay. Yes, sir.
Thank you very much for inviting me to give this lecture.
Is there a caller mic? Is there a caller mic? Dr. Brajesh, is there a caller mic?
No, unfortunately, we do not have one right now working. So,
So, yeah, and asking me to memory lecture in order to say, I have given a lot of, I've taken a lot of past lecture. the lecture is not a classroom lecture, but a lecture which is a general interest. I would like to get an idea of the type of audience that I have. So I will just request first, people who are students of MSc, please raise their hand. Thank you. Those who are the teachers and faculties, yes, please raise them. Those who are retired teachers, they will also raise. So that we have about 10 to 15, about 10 to 15 or 20 other faculty members. And I'm sure by the time I finish, there will be quite a few others coming. Okay. I'm going to talk today about the life and work of, as you all know, I, about 4 months ago, November 26th, created this life and work are tied up totally with the life and work of this university, as it is for most of the faculty members also, especially so for the Mitra. And so what I'm going to talk about, not only about Professor Mitra, but also about this department and the colleges in this university, which have grown up together to make what is called physics university. This is, of course, Professor Mitra, and unfortunately, we all lived in an era when photographs were not so easy to get. Nowadays, you can get millions and millions of photographs because you've got this mobile phone. So I had a lot of difficulty in getting photographs of Professor Mitra, not only for this lecture, but also for one or two other lectures that I published somewhere else. And so I'm very happy to get this photograph. It is, of course, finished. Who put it there, or the Pulshreshta or something else. And so this is Professor Mitra. Those of you who have not seen close can see this, but you were also very lucky because Professor Mitra became a professor emeritus 10 or 15 years ago, and so he used to come to the department occasionally. So many of you may have seen him there also. Let me begin with a brief history of the Department of Physics. The Department of Physics had a BSc course, or rather was helping to run the BSc course from about 1934 or so. Delhi University began in 1922. And as you can see, the MSc course in the Delhi University started by Professor Kothari and Professor Majumdar in 1942. And the first student in that course was one of my uncles, who joined in his department as a physics student. And then, of course, it developed, and both honors and MSc courses were taught in Delhi University. At that time, the Delhi University Vice Chancellor was an extremely well-known person. He was the head of the Federal Court, what was the Supreme Court of Justice at that time. His name was Sir Maurice Boyer. And he came from Oxford, Cambridge University. And so the Delhi University was patterned like a Cambridge and Oxford University, where the members of the colleges or faculty of the college, as well as the faculty of the department, taught various courses together. So it was a novel experiment. And along with Professor Kothari, at that time, Professor V.K.R.V. Rao, who also was a famous economist, was appointed at the same time. And the departments developed in the university. Now, special thing about Delhi University at that time was that quantum mechanics was taught in Delhi. Many of you here are physicists, so you know what is quantum mechanics. Quantum mechanics is a subject which really began in the year 1900 with the discovery of the quantum by Planck. But it really started as a quantum mechanics in 1926. In 1913, Bohr discovered that energy levels are quantized. But in 1926 onwards, Heisenberg and Schrödinger, Dirac, and other people discovered this quantum mechanics, one should say, or they started working in quantum mechanics. And Dirac and Schrödinger together derived the energy spectrum of hydrogen atom. And so it is often referred as the Dirac-Schrödinger hydrogen spectrum. And this was learned by Professor Kothari and others in Cambridge and other places when they came back here. But even in 1940s, Delhi, except Delhi and a few other universities were not teaching quantum mechanics. So physics department, Delhi University, was known for teaching quantum mechanics. And both Professor Majumdar and Professor Kothari were the principal teachers who used to teach it, and it was quite famous. Yeah, before I go to that, I must mention, at that time, because of these reasons, many bright students came to Delhi to study physics. And so at one time in 1950, almost all the research workers in PIFR and other places had all had their education in Delhi. So Delhi University was like a feeding ground of students for PhD and other things to other institutions like PIFR, Indian Institute of Science, and other areas. And so Delhi was extremely well. And this went on till about 1950 or so. In 1950, the situation changed drastically in physics. And I tell you towards the end of this lecture, right now also, I think there has been a drastic change in physics, but I'll come back to it at the end of this lecture. And in 1950, what happened was, quantum mechanics started making progress in an area which is known as quantum field theory. Quantum field theory is enlargement of quantum mechanics, and it is necessary to use quantum field theory if you want to calculate the energy levels of the hydrogen atom correctly. I told you that Dirac and Schrödinger calculated the energy levels of the hydrogen atom, but if you want to calculate them precisely, then you need quantum field. The trouble with using quantum field theory is that you have to do by perturbation. So you know that lowest level of calculation, that is the Dirac-Schrödinger hydrogen spectrum. If you want to go beyond that, you use the fact that the interaction, the electronic charge is very small, or E squared by H cross C, and you know, small. So you can do what is called a perturbation theory. If you have a perturbation theory, the perturbation theory series must decrease to make sense. If it doesn't decrease, then you can't calculate it. Now, it was found at that time that even the first order correction to the hydrogen atom was diverging, and therefore they could not really calculate anything at all. This went on, and during the period of 1939 to 1946, many of you may know, at least some of you may know, that there was the Second World War. The Second World War, which was the first war alive, of course, very well, but many of you are very young to know. And because of the Second World War, scientific work was at stop. So all the scientists were borrowed for war work. They were doing discovering radar, finding out more about radar, discovering about various other technical things that are done. And so because of that, scientific work was completely curtailed. After 1946, when the Second World War ended, of course, as you all know, Second World War ended in a very tragic way because though the war had ended, USA used the atomic bomb on Japan. Because of that, the tremendous, what should I say, cruelty that was imposed on Japan ended the Second World War. So when Second World War ended, the scientists came back to the university and started looking at various problems that were in physics and other areas. And the first person to do this so anyway, what happened was there was a lot of work discovering microwaves, and using microwaves, they found that the separation of two energy levels in hydrogen atom, which is called the lamp shape, was not zero, but it was a finite. That is, energy levels of hydrogen atom would not degenerate. They didn't have the same energy, they had a difference. And as soon as this was discovered, within a year, a famous physicist called Hans Bethe, who I will mention shortly in another collection of, Hans Bethe worked out the reason for this in what is usually called a back of envelope calculation. So you can, in a very simple way, calculate the lamp shape. And Bethe was able to show that this value can be obtained by using the higher order correction and using the idea that was called renormalization. Renormalization. Renormalization is if you find something becomes infinite mathematically, and which is what they were finding, that the hydrogen atom energies were turning out to be infinite, then what you do is you subtract one infinity from another infinity. You calculate the energy level at the lowest level, and then you calculate the energy level at a higher level, and you have to subtract one infinity from another infinity. And how to do this was for the first time shown by three great people. These were Schwinger, Tomonaga, and Feynman. And these three people show how to do this infinite renormalization. But unfortunately, of course, Schwinger and Feynman were in the United States. Tomonaga, the top one you cannot see anyway. Tomonaga was in Japan. And all these three people calculated, and they were able to show how to calculate using this infinite renormalization procedure. But at the time, nobody really understood what they were saying. Then a person called Dyson came on the scene, and the F.J. Dyson talked to Feynman, read all the papers, and finally he wrote a series of papers in which he showed how to use these calculations in a systematic way. And what he really gave is now called Feynman diagrams, because Feynman was the person who showed us how to calculate it. And in showing this, Feynman also used the very interesting fact that if there is a positron, you people all have heard of electrons, you people all have heard of positron. Positron is a positive charge in comparison to the negative charge of the electron. When you want to use the positron, Feynman discovered if you consider it as electron going back in time, then it is the orbit of a positron. So using this Feynman constructed diagrams, which Dyson explained to people what they are, and these Feynman diagrams then became very interesting. So in the 1950s, from 1950 to about 1956 or so, people were only calculating direction using Feynman diagrams. And in Delhi University, nothing of this was going on. So this was the problem. So Delhi University also had to find a new life and come up. So I'll come back to this. Let me go. Yeah, this is a brief history of A.N.Mitra, sort of capsule history. I'll come back to it again. Professor Mitra was born on 15th of April 1929 in Rajshahi in Bengal. Rajshahi is a famous town in Bengal, now in Bangladesh. And he did his PhD honors in 1947. He was only an underage. At that time, there was no age. And then MA Mathematics he did in April 49. And he joined immediately the physics department as a research student under Professor Majumdar. And Professor Mitra's father was himself a faculty member of Ramses College, and he was a teacher of mathematics. Mitra's father was a faculty member, and he taught mathematics in Ramses College. He was very well known in his own way. After joining the physics department, Professor Mitra, at that time he was Mitra, he started working with Professor Majumdar on radiative corrections, which I talked about some time ago. And he got his PhD in a very short time. Within 3 years, he got his PhD. And those days, there was a thing called Central State Scholarship. Then he gave a scholarship to other people for 3 years. And when the first on this scholarship, some took it, some didn't take it. Professor Mitra went on that scholarship to Cornell University in USA, and he spent time for another 3 years, 1952 to 1955, and he did another PhD again. And the famous people in Cornell at that time were Professor Hans Bethe, who I mentioned earlier, and Professor M.J. Dyson, who also I mentioned earlier. And Professor Mitra worked with both. And he had already done the radiative correction part of it here by learning it and working with Professor Majumdar. And he finished his PhD there also in 3 years, 1955, and returned to India and joined Aligarh University as a reader. And from 1955 to 1960, he was in Aligarh. Aligarh University is very close to the real. And the faculty members in Aligarh University were very close friends of Hari Majumdar. In 60, he moved from Aligarh to Delhi, where there was a vacancy of leadership. So he became a reader in Delhi University. And from 1960 to 1962, he was a reader in Delhi University. In 1960, he went to 1961, he went abroad as a visiting professor in Vienna. He was there in 1961 and 62, or 62 and 63. 62 and 63. And in 63, when he came back to India, Delhi University, Professor V.S. Kodhari and Professor Majumdar appointed 3 professors who were relatively young. One was Professor Mitra, another was Professor L.S. Kothari. And the third professor came a year later in 1964. It was Professor S.N. Biswal. So these were the 3 young professors. And with their coming in, and with a lot of other changes, which I'll talk about now, the Delhi University again started recovering some of its past glory and again become an important university in the whole of this area. Now let me come to a brief family thing. Professor Mitra married Anjali Ghosh in 1956, and they had 2 daughters, Bani and Gargi. Bani unfortunately died, and Mrs. Mitra herself died here, and Professor Mitra of course died 4 months. And if I remember right, I'm not sure that I'm correctly, I think Professor Mitra's sister married Anjali's brother. So it was a kind of an interesting kind of a marriage. And so this was the family life. And in the year 2014, there is a journal called Current Science. There is the Indian Academy of Science. This is a well-known institution. They started a practice of identifying living legends in Indian science. And the first person to be identified as a living legend in Indian science was but the next one was Professor Mitra, Ashok Mitra. And at that time, they asked me to write something about Professor Mitra. So I was in a total fix because it is easy to write about the person who is no more, who is alive. To write about him is a very tricky thing because you have to be sure that you are also not offending that person. But later on, I realized it was also a very good thing because most of us would like to know what others think of us, especially their good things about us. But if you are written about only after you die, then it is impossible to know what is going on. In fact, even the great Professor Chandrasekhar, who I got to know when he was in Chicago, he always used to worry about other people think about. So I was thinking, people must tell him what they think about. Right at the time when I was in Syracuse in 1980, Peshwari decided that he will write a book on Chandrasekhar. And that was a very good thing. So he wrote a very good book on Chandrasekhar. So Chandrasekhar would know what people talk about him. So in that sense, it was good that I wrote this article. And I was also very happy when I received immediate response from both Bani as well as Dargi. They said, we didn't know so many things about my father. And you're so glad you wrote. So in a sense, later I was happy I wrote about it. Luckily for me, Professor Mitra also told me, I'm glad you wrote a nice article, including the report. So that is very good. And this is about renormalization of all this. Yeah. Now, let me look at Delhi University briefly, year 1959. As Brajesh mentioned, I was in the IIS for a short while, but after passing my MSc, I started working with Professor Majumdar. And the Professor Majumdar had a small room which four of us used to sit. And all of us are calculating radiative corrections using Dirac equation. And some of you are familiar with Dirac equation. There are matrices that called alpha, beta, gamma. And so you use the alpha, beta, gamma matrix. But it was impossible to work with. We did not know that Feynman had completely revolutionized the subject. So anyway, after that I decided I want to go into the IIS. So I went into the IIS and I resigned from the IIS in 1959 and I came back here October of 1959. I had written to Professor J.S. Kothari, so both Ali and Majumdar gave me a temporary job here. And then I met Professor Majumdar. That told me, nobody to whom I can send you right now. So you do one thing. You go to NPA. So NPA at the time had a registrar, IAS person, introduced me to him. So I went to meet, and when I went to meet him, also three others, one of them is right here. Devanand is here. Devanand was one of them. Another was H.S. Mani, who had just passed MSc along with Jay. Another was Chandralal Mehta. So all three of us went there, talked to the registrar. And then he said, we have a very important physicist called Gyan Mohan, where we talk to him. So we talked to Professor Gyan Mohan. And Professor Gyan Mohan said, well, the new thing in physics is what he called LSZ, or Lehman, Semantic, Zimmermann formalism. So I can give you lectures on Lehman, Semantic, Zimmermann formalism. So you come once a week. So we all went once a week. But somehow we didn't follow everything, nothing worked, and that came to really nothing. But then Professor Mitra and Professor Majumdar made a lot of changes in taught life. One was, of course, the appointment of three professors. There were also other things. One was Delhi University became a center for advanced study in physics. There was a special thing that was created by the University Grants Commission. The chairman of the University Grants Commission was Professor J.S. Kothari. And not only was the chairman of the University Grants Commission, he was also chairman of the Education Commission, which was set up and gave its report in 1964. It is a very famous report even today. So both were extremely well connected with the government, so it was easy for them to get government funds and started. And Russia donated Kapitsa's liquid helium plant to Delhi University. That was also set up because you can't do theoretical physics alone. You have to do experimental physics also. And so this liquid helium plant was actually set up and run by Professor K.D. Chowdhury. Professor K.D. Chowdhury had been to Cambridge and worked in low temperature science, and he came and set it up, and a lot of very good work was done. The Ramaseshan, well-known person, was director of the Indian Institute of Science, when he came, he told me, I'm so happy for you. From many places where they have good equipment, they don't use it at all. And then at the same time, CSG.K. Shetty, who had done his PhD in Cambridge, in ionosphere, he started ionospheric study, and he had a huge big lab in the place nearby here. And then we had no electronics at all. So Professor Majumdar told me, I'm getting somebody. I know Krishnaji. Krishnaji was the famous electronics person in Allahabad, and he will send us a good person. And so G.P. Srivastava, he was also an extremely intelligent and good person, and he set up all the electronics labs. In fact, the electronic labs were set up so fast, they got so much funds, there was a lot of friction in the department. So finally, electronics went as a separate department in the South Campus, and it's now a full-fledged electronics department. And then at the same time, Professor Bhowik, who was very unhappy, he was not being promoted, set up his own emulsion lab. I don't know, some of you may be familiar with emulsion lab. When you detect particles, earlier there were instruments called Geiger counter. Use them to detect the particle. Then you had the bubble chamber. But then you also have the photographic emulsion, in which particles, and so you can get the photographic emulsions, analyze them, and study what are the interactions. And that is what Bhomik started. And he worked very hard and set up a very small and very strong group. One of the members of the group was Shivpuri, who later joined the Fermi Lab, then also joined the CERN to bring Delhi University into the picture there. And we also got some very bright people. One was Madanlal Mehta, who was brother of Chandralal Mehta, who went with us to MBA. Madanlal Mehta was absolute brilliant fellow in mathematics. And later on, he also worked with Professor Dyson in Princeton and worked on what is called random matrix. And at the time, the department name and also Haridas was given name to Calcutta later. Then you forget it. And the department's name was also changed from physics to physics and astrophysics. Because at that time, Kushwaha was here, who was astrophysics. Okay, so this is a brief summary of the same thing. He was the chairman, and at the time, Professor Olak was here teaching mathematics. And Professor Olak was one person whose PhD thesis went to Schrödinger as an examiner. And Schrödinger praised the thesis so much, Professor Kothari always began the year by telling us about what Schrödinger wrote about all. And then Professor N.K. Saha was a person who had worked in Germany on Geiger counts. And of course, there were very, very bright students also who joined them.
Raja, CTS go when CTS of Raja.
Or I will come to Raja. Raja, he went to corner. Now, many of us here, in theory, in particle theoretical particle physics, even now has this unusual behavior that not everybody comes up with new ideas. Some people who are leaders in the field come up with new ideas, and if they use the develop the idea, they should be. And other people also will quickly follow this and incrementally change the subject. That is how particle physics has been progressing. For example, Delman, who was a very famous particle physicist, discovered SU3, and then everybody else joined in SU3 and also calculated various. Similarly, current algebra was also started by Delman and other people joined later on. And the LSZ formalism that I mentioned was also started by Lehmann, Zeman, Sigrid, Zimmermann, and then continued by other people. And there was an absolutely novel way of dealing with particle physics, which is called bootstrap hypothesis. It was developed by Chu. And his idea was there are no fundamental particles at all. Each particle combines to produce the other particle. And what we have now is a mixture of Chu's bootstrap theory with the quark model, which is supposed to be the fundamental particle. And this is how it goes along. Now, if you are a person who wants to do something on your own, is not that at because you have what is usually called bandwagon physics. You climb on the bandwagon of physics and try to do the same thing over and over again. So Mitra decided he will do something else, just something different. After about 5 or 6 years of doing this renormalization theory and other things. And in 1961-62, Mitra found a special subject which he could pursue. Special subject really turned out to be one of the very, very old subjects. What is the old subject? This is what is usually called a few body problem, or it can even be called the 3-body problem. Because as most of you who learn mathematics and you learn physics know, if you are dealing with 2 particle interactions, it is rather easy. You know how to do it. You have a 2-particle problem, separate the center of mass motion, and then you take the interaction of the 2 particles, and then you calculate how it works. But the moment you go to 3-body problem, even in classical mechanics, forget quantum mechanics, even in classical mechanics, it is impossible to go ahead. In quantum mechanics, suppose it is even more difficult. The problem with Mitra, I have a suspicion, I'm not sure, and he is no longer alive, that this he must have taught even in any mathematics, because all the mathematicians know that a three-body problem is impossible. So what he picked was the three-body problem. And he found that if he used a separable potential, it was used by Faraday and others, he can produce an exact solution of the three-body. So he got very excited about it. And he started this three-body with separable potential. And we really became masters of this subject, separable potential. These are the three achievements of his that I've listed in three-body problem. Of course, we had 220 papers published, so there are a lot more to it than what I'm telling you here. And you can see here, the first was, these are in Mitra's words himself from his reports. That solutions of the nuclear three-body problem, separable potentials, a new insight into the structure of the three-body wave function, giving rise to few nucleon studies as a new branch of physics. This was the first achievement. Second achievement was, we found that when he calculated the proton, it is called the electromagnetic form factor. The electromagnetic form factor is not a simple wave falling off, but it is a wave with a load. That is, it is not a S wave, as we say, it's a P wave kind of. So electromagnetic form factor has a node, which means that you can't assume it to be the lowest numeric one. And for proton, he had found it, but this is also true when you consider the proton as quark. So it was clear to Mitra immediately that there is some problem here. You need another degree of freedom. If you're going to use quark to make your proton, you must have another degree of freedom. Otherwise, Pauli principle, which many of you must be familiar with here, Pauli principle will create a problem and you will have a node in the form factor. And so now we have what we want, not just one type of quark, but three colors of quarks. They are often called red, blue, and green, but there's nothing to do with the color as we know it. It's just degrees of freedom, separate degrees of freedom. Unless you have them, you can't form a three-quark model of proton without getting a node in it because of the Pauli. So this was the second discovery. And the third discovery at the time is often called the quark recoil effect. That was did it with Mark Ross. And this shows the heavily zoned decays will increase in their strength. Well, he set up his lab in Delhi, and at one time he must have had 10, 15 students working with him. And all told, he must have had more than 30 students. I don't find a list of students given anywhere. Whereas Chicago, Chandrasekhar told me 36 students of mine has got his PhD today. So, kept a very careful account of how many PhD students were producing. Somehow, all the reports about Mitra, I don't find the number of students he had. Many of you here may know more about it. But I think he must have at least had 30 to 50 students in the, and most of them were in the colleges or in the department. Now, Professor Mitra was the senior most professor, and he also became head of the department in 1973. But before I go to this being head of the department, I must tell you briefly something about change in the Delhi University also. The Delhi University at that time in 1970 was also like most other departments of all over India, that usually called feudal. That is, once you become head, you are head for all your life. So once a person became the head, he retired at the age of 60 or 65, he was the head of the department. And so he could go anywhere and get away. But in 1970s, we had a first vice chancellor, was a young vice chancellor, was an economics professor, unknown economist, called A.N. Raj. A.N. Raj became the vice chancellor. And unfortunately, it was very difficult to serve as the vice chancellor. He lasted as vice chancellor only for 1 year, 1971. But within that 1 year, he set up a lot of committees, tried to change a lot of things in Delhi University. One of the committees went into the question of the head of the department. And I think in that committee, Professor Rajaraman was also there. So that committee gave its findings, and the other companies also gave its findings. But before these findings to be implemented, Ken Raj resigned. But luckily, his pro-vice chancellor, Swarup Singh, became the next vice chancellor. And he had the patience and the ability to deal with all these political things. And he changed the rules and ordinances of the university to implement the head of the department committee. So after that, almost all departments, the most member is appointed as head only for 3 years. Or if he reaches the retirement age, so this is the rule. But unfortunately, this hasn't been a pure blessing because this has brought in vice chancellor, this has brought in heads of departments who are not interested in being head of the department because they are senior most they become heads. Whereas, like in IITs, you should choose the department and give him 3 years or 5 years or whatever it is. Unfortunately, in Delhi University, even now, unlike IITs and good universities in the West, you don't have a board of trustees or a governing body. You know, vice chancellor mostly everybody forgets what is going on in the university. So because of this present method of head of the department appointment also needs a change, but we need another Raj and Swarup Singh for it can change it. Yeah.
Sorry, no.
I thought I was loud enough because I'm used to speaking in this one. So, the Mitra also began with great enthusiasm. Yeah. Right. So, Mitra also with great enthusiasm met all the faculty members, asked them about the syllabus, what the changes and all, and started streamlining the administration. But very soon, he also hit roadblocks. He found there were a lot of difficulties. And unless he was able to put in very much more time than he can, he could not. Midway through the term, about 1.5 years or so, he resigned. And Mitra himself succeeded F.C. Onan, who was the head of the department. And when Mitra resigned, L.S. Kothari became the next head. He also served only for 1.5 years, and then he had to resign. And then Professor Biswas became head of the department. He also served only for 1.5 years. It just shows that there are two things. One is a person who is very good in physics, he will not be a good analyst. That is certainly true. But that is not the only thing. Another reason is if there are 2 or 3 bright people in one place, they should learn how to get on together. If they don't get on together, then also. So these are all problems of our institution. I will not go more into it. Now, when did I start? 325? No, 325 is right. You see, now I want to briefly discuss some things that happened while Mitra was here, either as head or as a senior professor. The first thing I want to talk about is lectures, seminars, and colloquiums in the department. See, the physics department at Delhi University always hosted a large number of foreign and Indian students. Every institution has to have a system of lectures, seminars, and colloquiums for the students to learn about what is going on in their subject in the field all over the world. And this was true in Delhi University especially. And this hall is especially famous because everybody famous who came to the department gave lectures in this hall. In this hall, I heard Linus Pauling, I heard A.N.Mitra Brackett, I heard Donald Glaser discovered and got the Nobel Prize for bubble chamber. And then Shapley, who was a brilliant astrophysicist, and Shapley introduced, he had, of course, we had those projectors and all. He had a photograph of Chandrasekhar on the projector. And he said, I don't know whether you people recognize this picture or not. I normally use this picture to focus my projector only. But then we realized that it was Chandrasekhar he was referring about. Anyway, so, and we also heard Harish Chandra, the famous mathematician. We heard E.C.G. Sudarshan, our own great physicist. Then Hans Bethe, Dick Dalitz, Homi Bhabha, Yash Pal, Namukunda. In fact, I remember, I'll come to it shortly, Professor Mitra organized a special conference on Q-body problem. And at that time, apart from Professor Mitra, Professor Dalitz was also working on quark model. So quark model, so Dalitz came specially and he gave his lecture in this hall, right standing in that region. I remember very well. And this was going on all the time. And in 1972, a particle physicist from US was invited by one of the faculty members, and he was asked to spend some time and give a full lecture. And unfortunately, this member, who was from the Princeton to the Advanced Studies, was also a member of a committee on war, which was advising the US government, especially the Vietnam War. I don't know how many of you people remember. In 1960, 60 to 70, America was fighting Vietnam. And so all the Americans were being drafted. There was a lot of opposition to Vietnam at this time. The US was really burning at the opposition to Vietnam. So he was one of the advisors. Now, when this lecture was organized, the organization in the university discovered that this person was a member of the committee. And so they decided to protest and they won't get in lecture. So right in this hall outside here, a huge scuffle was going on. People were trying to come in, people were being stopped. And I remember JJ was there standing, and another leftist friend of mine, Ashok Goel, was there, he was also standing. So Ashok Goel would not let people come in. JJ said, no, let him come in. So finally, JJ picked up Ashok Goel. Ashok Goel was on his side. JJ picked up Ashok Goel was on his side. But all they did help. The lecture wasn't held, it was cancelled. And it is also difficult to decide whether this was right or wrong, because when it comes to ethics and science, you can't always say that science can do what it can. Come back to it also. The lecture was cancelled. But cancellation was not the only thing that happened. Newspapers were full of it next day. It went to the parliament also. And this was in 72. In 73, Mitra became professor. 73, by chance, I discovered a huge big file with Professor Mitra, which had fallout of all this. Because the parliament had taken the question what happened, the Ministry of Education had taken the question what happened. And all these people, once they take up these questions, what they do is they put a whole lot of new rules. You can't invite so and so without asking us. We can't do it without asking us. And that is what really happened. A whole lot of constraints were put. And Professor Mitra patiently was answering all of them, telling them we must have autonomy, we should have freedom of speech. The education institution cannot survive without that. But I was amazed, he did not tell anyone else about it. So he was answering and doing all these things, wasn't taking any credit for it. Yeah. See, what amazed me was the fact that Professor Mitra never mentioned or took credit for all his efforts in trying to minimize the constraints that the government was trying to put on us. Probably that was the most natural thing for him to do. He says, I am an academic, so I have to defend the freedom. That is all. Anyway. It's always an achievement that these ministers have. As I consider his biggest achievement was organizing the International Conference on Fluid Body Problems in December of 1975 and January of 1976, and editing the proceedings in the Fluid Body Dynamics in North Holland in 1970. The conference was held here. This was the main hall, and its subsidiary things. And he got the Bhatnagar Award in 1969, and he was one of the first theoretical physicists to get that award. And he got that award for showing that a proton has a no, therefore there must be a degree of freedom along. And I remember at that time Swarup Singh was the Vice Chancellor. He took his pro-Vice Chancellor and came special to congratulate him. Then he got the Meghnad Saha Award in 1975, S.N. Bose Medal in 1986, A.N.Mitra Medal of the ISC, and he was a fellow of the Indian Academy of Science, Indian National Science Academy, National Academy of Science Allahabad, American Physical Society of the USA, Third World Academy of Science. It was in Trieste at one time, the New York Academy of Science in Europe. Now, yeah, this is somewhat earlier. See, Mitra traveled widely abroad and gave lectures. spent a lot of time abroad, spent a lot of time in ICTP, TSA, to which many of us also went. And but wherever he went, he always lectured to students. Either he took classes regularly here, or there is regular quota, or he went lecture. He was an excellent teacher with a distinctive style. Though in early years, he has to face some problems. Soon after Delhi, he joined Delhi University. Some students found his detailed arguments and derivations difficult to follow in the class. And they went and complained to Professor Majumdar. I know who complained, but I should not tell you what else. Anyway, so Professor Majumdar spoke to Mitra about it. But then Majumdar did not anticipate. Mitra promptly submitted his resignation and stopped coming. He was in Deriaganj at the time. So Professor Majumdar had to go several times to the house to persuade him and come back and do this. And also, this is also another. They said many people used to come and give lectures here. And one of the persons who came and gave a lecture was Professor Mukunda, who many of you here know very well. He is a brilliant. Now, Professor Mukunda, you see, Mitra has a way of underplaying himself and trying not to take the center stage, which sometimes leads to amusing situations. Professor Mukunda was once giving a lecture at Delhi University. Mitra came in a little late and tried to sneak in quietly and take a back seat. It was not in this room, but it was in the other room. He tried to go to the back side. Mukunda passed and told him, please come forward, don't sit. So Mitra immediately said, no, I'm only an observer. Please ignore, please ignore. So Mukunda said, when the observer comes in, the wave function collapses. You cannot ignore it. If you want to make errors, if you are a superposed state and you're making a measurement, then you move to one of the two eigenstates and we call it the collapse of the wave function. So, and you say that the observer comes in, the wave function collapses. So Mukunda said, this is what is really happening. So Mitra was then came forward and said, and then let me also tell you a brief story of Mitra as a mentor. See, Mitra was a role model himself. So he doesn't have to tell you to do research, because he is doing research and you know you have to do research. He was a great influence on the research work done at Delhi University, including colleges. And Mitra also tried to identify people who he thought were good or who could be elected to various academies and propose the names to the academies and push them. This is something I found, which is Chandrasekhar also doing in Chicago. He would identify people, recommend them to Royal Society. So Mitra used to do it systematically. But unfortunately, he didn't succeed in many cases, but in some cases he did succeed. In one particular case, again, I won't mention the name of the person, he failed because fight was not between the academic people and the proposer. It was fight between teachers in the Delhi department, university department itself. So that was a very sad situation. And that kind of thing was what I was mentioning earlier. Senior professors often disagree. Sometimes they discuss among themselves and do the right thing. That is what Kothari and Majumdar also did, because they did not think along the same lines. They had completely different ways of thinking, and they had always most of the time they agreed, but some of the time they differed. But when they differed, they discussed and then did a common thing. But unfortunately, professors in our department haven't always done that. That has not been very good for the department. And of course, one advantage is if the head of the department changes very fast, is one way of changing it. These things have to be optimized. That's all. Yeah. After retired especially, Professor Mitra was writing a lot of this, what can be only called useful book. And this is a book called World of Physics Then and Now. It is a big fat book. Mitra took 5 years to publish the book, 2005 to 2010. Professor Ramanna told him, you must this book published. So he took it as a mission. And because he was well known, he could ask people to write. There were articles by all the A.N.Mitra was there, Mukunda was there, many other people were asked to write. Chairman was there. Everybody wrote in them. And it is very but unfortunately, you see, not only did it take 5 years, it that book, and it cost 2,200 in 2010. Now it would be probably 5,000 rupees. So who can buy a book like that? A young person who needs a review of subjects, this is useless. Also, things are now changed. Now we've got Wikipedia. If I want to know about somebody, I go to Wikipedia. And I don't pay a pie, I just use money. So we have to rethink about these big books. But it is a very interesting book. And Professor Ramanathan is here. He also helped Mitra doing this book and all that. And he spent 5 years doing the development. Now, I will take another 5-10 minutes to finish. Professor E.C.G. Sudarshan, many of you might have heard of him. He was invited to give the Nehru Memorial Lecture once in Tirumurti. And he said that the present generation, if you want to look for Rishi of the ancient time, who tapasya and are committed to their work, then you have to go to science, because the scientists are the people who are really tapasvis and who do this hard work, and they are able to be totally non-committal. And this was also brought to us in our classroom, because Professor D.S. Kothari, while giving lectures in the classroom, will of course talk physics, but quite often we will go away and discuss stories. For instance, he would tell us stories about how Professor Orlick's thesis was praised. And he also told us at one time that Lord Rutherford was a very famous person for the Nobel Prize, and he was the first person to show what is the size of the nucleus and all that. He said he never had much money because he never bothered about it. And Dirac also never bothered about it. But of course, Dirac was lucky. He married Wigner's sister, who was a shrewd Jewish lady, and she made sure that he had enough money with him to take care of it. Whereas when Einstein was asked by the Princeton people, how much salary you want, $3,000 should be okay, he said. They were thinking of $300,000, and he was saying $3,000 would be okay. Then the person said, okay, Professor Einstein, I'll talk with your wife. You better. See, maybe we are tapasvis, but we should not carry it too far anyway. So, but I think I'll come back to it. Now, people used to make fun of J.S. Kothari also. They used to say, he wants us all to do tapasya on the banks of the Jamna, sitting on a sackcloth and wearing ashes. Now, but luckily, when we were in 1960, Geshwant was the finance minister, and he raised the salaries of all the lecturers from 400 to 750. We are very happy that Sri Geshwant at least did not believe that we should sit on the banks of the Jamna and do that. And yet, one cannot but admire such commitment. See, we all have a natural feeling for people who are committed to their subject so much that they don't think about anything. In fact, Mitra, Professor Mitra, in Trieste, often used to work whole day in the library and often sleep in the library also. So then, Abdul Salam, who knew Mitra very well, used to tell him, no, you should not, you should go back to your appointment and then sleep there properly and have proper rest. You see, and Salam used to say, one should learn from Western countries, not to underestimate oneself. And before I show the next one, you see, in Delhi, we can take the case of DSK, RCM, A&M, and SMT. Yeah, in the 1960s, when the young stars of KFR visited and talked in this lecture hall, to Yashpal and 2 or 3 others who gave this hall, they were very impressed. They were so confident. They came flying by air, they went by air. Those days, air travel was actually impossible for all of us. And Then we said, these children live so well and also do science, and we are here trying to do science. Nothing really with us. Now, of course, things have changed. Teachers are being paid well also. See, talking about foreigners, when Stephen Weinberg was called to the University of Texas, he wanted, apart from a high salary, a job for his wife in the Faculty of Law and a corner office. The corner office was a very famous thing in America because they all liked offices which opened on both sides of them. And see, in Delhi, we can take the case of these people. These are all extremely simple in their life. A.S.K. Majumdar, Mitra, Biswa, and Professor Kothari. And but Professor Majumdar persuaded the Education Minister Humayun Kabir to hold summer school. And we had summer school every alternate. And they were very nice places. In fact, many people who have heard about the summer school know that they were brought the whole physics community together in the country. And Professor Majumdar insisted to stay in good hotels, not really in the dharamshalas and things like that. And Homi Bhabha also wanted this, and the Tata Institute, they were given, and you see, Abdul Salam, of course, created the ICTP Trieste, where you could go and stay for 3 months in India and spend everything. And now, of course, we have this IU class started by J.V. Narmithun, where also there is treated and given respect, and also shown why you should not necessary. So, but now things have changed. The teachers' salaries, even school teachers' salary, they are extremely good. But unfortunately, you cannot get the job. Even the university salaries are very good. But you can't get the job. You hang around for 5 to 10 years as ad hoc or whatever. Then you are lucky that once you get the job, of course, then you're okay. Like in America, I remember when I went to Chicago, I went as a fifth-month scholar, it was called. I was getting $3,000 there. Nambu told me, something your PhD. Joined as a postdoc. So I was a postdoc getting the 3,000. But then, after I finished the both of them, Nambu told me after some consideration that we will take you as a postdoc for 1 more year. Immediately, my salary went to $7,000. You see, so their salaries there are quite high. And fortunately now, even though we are being paid well, the jobs are scarce and permanent jobs are not really. Now, this was all about the past. Now I'll go talk about the present and the future a little bit before I stop. You see, what is the situation in the first quarter of the 2000 or second week? I retired in 1998, 25 years ago, almost. A whole generation of teachers has come and gone since then. You're all part of it. Most of you also. In 2000 to 2005, Deepak Nair, Vice Chancellor of Delhi University, recruited a lot of new young teachers in the department. Then Professor Raja Raman and Professor Today, I learned from Professor Brajesh Chowdhury that you are appointed 14 people. It's a big number. And I hope they are all good because you see, they are going to man the department for the next 25, 30 years. So it is very important to appoint people who are very good. I'm sure you must have bothered them. So, see, then I enumerate the personnel you are appointed, you are all very kind. So there was really no question of they're not doing well. I'm sure all of them must have been very good teachers and very good. Some of them I knew personally and work with. So I don't find too much change in this. But in physics, astrophysics, in science, I find everything totally changed. See, come to condensed matter. Condensed matter physics is full of quantum field theory. All the Dirac matrices we use for Feynman diagrams are now in condensed matter physics. And not only are they in condensed matter physics, They are in two-dimensional quantum matter physics. Because in the two-dimensional film, these are applied more in another place. And in the quantum matter physics, they are talking of time crystals now. You heard of space crystals, where there is regularity in space. Now you are talking about regularity in time, and you are talking about time crystals. In particle physics, we have found our hits, but no supersymmetry has been found. And hence, the string theory just cannot work without supersymmetry. So unless there is a miracle, somehow supersymmetry is found somewhere else, how are you going to go ahead with supersymmetry? I don't know. And we have discovered gravity waves. It's a remarkable technological feat to discover such a small violet fluctuation using a fabric-oriented interferometer. It's quantum mechanics, because quantum mechanics puts so many obstacles in measurement of quantities. We have to discuss this very, very carefully. It's an absolutely remarkable technical improvement. And because of the discovery of gravity waves, we also now have evidence for black holes. And we know the black hole mergers and the calculations that were drawn by many of my friends in Bangalore and other places, like Bala Iyer and all, they've all been verified. And now we have to believe in black holes. Not only do we have to believe in black holes, every galaxy has a black hole at its center, and it is controlling the galaxy. It is the black hole at the center that is controlling the galaxy. And now the latest is the James Webb Space Telescope, which has with great difficulty put in a very particular place and has been remarkably successful in working as well as in sending signals back to us. And because of the signals it is sending, it looks as if the cosmology is going to change completely. Because we thought no galaxy could be formed before a certain time, but it looks very much like we have galaxies even before that time, which you are now seeing. And quantum mechanics, as Feynman kept saying, nobody understands quantum mechanics. In quantum mechanics, you don't understand quantum mechanics, but entanglement has brought in new change in philosophy. If entanglement can last over distances which are not very physical, then it can do actually brilliant wonders. And then, of course, we have artificial intelligence. Artificial intelligence is making slaves of all human beings. Once this artificial intelligence comes, everybody can go home, they can do everything without you at all, and this is what it looks like. But on the other hand, in life sciences, there is something new called CRISPR. You all must have heard. CRISPR. CRISPR is something enables you to edit genes and put in new things. And I'll tell you a story about that. The CRISPR permits you to edit genes in an inheritable way. Once you change the gene in a particular way, then that thing can be inherited also. And in fact, in China, one of the experts in this field, the embryo, make some modifications, that the embryo won't get HIV disease at all. And that is inheritable also. And a few days ago, I heard a JNU professor who is an expert on Tibet telling me that Chinese are completely trying to change Tibet. Tibet has about 50 lakh Tibetans or something like that. They brought 50 lakh other Han Chinese into Tibet, and they also put them there. Now the Tibetans there already can stand the cold. The Han Chinese cannot stand the cold. So they are finding difficulty to stay there. So what they have done is they are trying to use CRISPR so that their genes of the Han Chinese are modified so that their children will be able to stand the cold better. So what has CRISPR really done? It has made gods of men, whereas the artificial intelligence had made slaves of men. So science is really completely revolutionizing the world. And unless we have real good wisdom, or unless we have a good ethical system to guide us, we are going to have tough time deciding what just let the market take the way forward. It is not going to be good for the country.
question? No, no question. So, a small, gratitude on behalf of the department. And this is 100 year of the university. So this is the Delhi University's folder and this is Department of Physics.
So I have the pleasant duty of proposing a vote of thanks on behalf of the department, all the members of the department, both past and present. I express our gratitude. Now, no one could have better articulated all the facts that he told us today about Professor Mitra and his work and his life. And one luminary talking about the other is not something that happens in the Escapari every day. So thank you for that, sir. And thanks also for taking all of us on this exotic journey about the life and work of and the contributions of Professor Mitra to science. And for this, sir, we are very grateful to you, and for this, you deserve. Ms. Gargi, this memorial talk has been made special by your presence, and thank you for being here. For our predecessors in the department who have faced this occasion in spite of the heat, the soaring temperatures, and those of you who have joined us online, thanks a lot. Thanks to the university for granting us a special grant for this memorial talk, which is rare in the department. Even regular events won't take place because of lack of funds, and this was a first time for us, and thanks to the university for this. Last but not the least, I would like to thank the head of the department, his office staff, Mr. Davinder, Professors P.K. Ranjan, Yogira, Saurav Sur for making this event possible. Thanks a lot. And thanks to the students who have joined us, and the students, the postdocs. And now I invite all of you to tea and snacks and lunch. Thank you.
चलिए बहुत चलिए बहुत ये हमारी नई पार्टनर के बहुत चलिए आप लोग आ जाइए सारे लोग आइए बहुत
हमें मिल गया अच्छा मिल गया है टीचर से है क्या टीचिंग के लिए